Hello, this is Lab 1 in the Fundamentals of Physics course, and it's on constant velocity. The purpose of this lab was to analyze a video on Tracker and construct a model on VPython to predict the motion future of a system using Newton's second law of motion. So what is Newton's second law of motion? Well, it states that an object's acceleration or change in velocity equals the net force on the object divided by its mass. Here shows delta v, which is the acceleration or change in velocity, equaling the net force divided by the object's mass. To predict the motion feature of a system, we had to predict the position and velocity of it. To predict the position, we knew that delta p, which is the change in position, equals the average velocity times delta t, which is the change in time. So we did some algebra on it. We added the initial position to both sides, and we came out with the final position, which is what we want, equals to the average velocity multiplied by the change in time plus the initial position. To predict the velocity, we did some algebra on Newton's second law of motion by adding the initial velocity both sides. And the outcome came out as the final velocity equaling to the F net, which is the net force, divided by mass times delta t plus the initial velocity. So here's my video on Tracker. I use the center of the wheel on the car as my center of mass, center point. And the ruler taped onto the wall was used as my calibration stick, and it was 30.5 centimeters. And as you can see, the origin I placed at the left side of the screen when the car was at the left, so it was placed in the middle. And the car rolls down the positive x-axis. So here's the graph on Tracker, and here's my data. The time and x. The time starts at 0 and ends at 2.167 seconds. Here's my Python program for my computer model. The toy car's mass, initial position, average velocity, time, and delta t are set at the beginning. After the while loop, the net force is set to 0. And now is where the velocity and position are set. So first, the initial velocity or position, depending on which one you want, is passed through the equation that was shown before in the PowerPoint presentation, also depending on which one you want, velocity or position. And the equations are also shown here. So this equation returns a result or value, and that will become the next initial velocity in the while loop. So if you can see, each time a new initial position or velocity is made, and it goes through the loop over and over again, so that you get a new one every time, and the older one gets recorded. So it results in our motion future being predicted. Now if I run the Python program for you, you will see my model. So this clearly depicts that my car was moving on the positive x-axis, as so does the sphere shown here. And the graph shows that it's moving, that it is on the positive x-axis also. So here's all my data on an Excel file. This is for the model that was created. So the Python deposited a CSV file, and I copied that onto this file. And the tracker data, which is here, which I copied from Tracker, the T and X. So this is the model versus experiment data chart. The x-axis shows time in seconds. The y-axis shows position in meters. You can clearly see that the results aren't exactly the same, but it's pretty close. This could be because of the fact that we set that net force is 0 instead of actually calculating the net force. We are now finally at our what if question. What if the average velocity was turned into a negative? It's being run, and you see that the ball or car travels in the opposite direction, or the negative x-axis. As so, also, it's seen in the graph. As final question, we were asked, what does it mean? Is it possible for you to say how many pushes and pulls are added together to give zero net force in the case that you observed? Using Newton's second law of motion, we can tell that all the forces are combined into what is known as the net force. So there's no way in separating this net force. So I conclude that it's not possible to say how many pushes and pulls are added together.